In today's lab, we will be using a pH meter to help us determine the pH of an unknown. Before beginning to obtain the pH of our solutions, we had to prepare the pH probe first. We made sure we had a waste beaker, distilled water, and some chem wipes. Once the meter is removed from the storage bottle on the bottom, it needs to be held over the waste beaker and washed with water. Instead of wiping the meter dry, we made sure to gently dab it with a chem wipe. Then we had to move on to the next step, calibration. For this lab, we used a 2-point calibration, which means that we first put the probe into a buffer solution with a pH of 7. A buffer is a solution that can resist pH change after the addition of an acid or base. It's able to neutralize small amounts of added acid, or H+ ions, or base, OH- ions, which maintain the pH of the solution. After measuring the pH of this buffer, we washed the probe again and properly dried it before placing it into another buffer with a pH of 4. This is a more acidic buffer because we needed the meter to properly calibrate to some of the acidic solutions we would be measuring later. We were then able to test the pH of an unknown solution. Since we calibrated the meter properly, it would show us a pH of around 3 when input into the unknown. This told us that the unknown solution we had was acidic. Speaking of acidic, I'm going to talk to you guys a little bit about proton dissociation while the rest of us do the unknown. One difference in the proton dissociation behavior between a strong and a weak acid is that strong acids tend to dissociate completely whenever they're in a solution, and weak acids will not dissociate completely. This proton dissociation is important when affecting equilibrium because since strong acids dissociate all the way, when an acid dissociates, they release H+ protons and it makes the solution acidic. So when you have a strong acid that dissociates all the way and it increases the number of protons in a solution, it means that it has to have a weak conjugate base in order to create equilibrium. A quick look at our lab notebook tables showed that the acids that we were measuring were closer to 3s and 2s, and the known solutions that we had already measured, such as the buffer and water, they stayed really close to 7 like they were supposed to be. After we were finished with our experiment and we were ready to leave, we began our cleanup process. So you have to take the cap that's on the top of the probe and wiggle it down a little bit so it's closer to the bottom. Then you find the storage solution that it came in and you make sure you tighten it back on. That way the probe doesn't dry out. Then you make sure you unplug everything, such as the meter, and you'll make sure that you unplug it from the power outlet itself. Then we take it back up to the front and stored it back in the box. Using the data that we got from our actual experiment that day, we could tell that the solutions that had like hydrogen ions in them, you could really tell that they were more acidic in pH than the hydroxide ions, which is what we mentioned earlier talking about the weak conjugates and strong acids.